Is it visible for everyone?
Yes, sir.
Yes.
Yeah. So this mole concept, we will talk about the basic structure. Huh. Thermal energy is really important when we do kinetic theory of gas. The thermal energy of particle. Gas have maximum energy, thermal energy, and uh, solid have minimum thermal energy. So TE is thermal energy. Okay. Then intermolecular force. Solid are very close to each other. So more intermolecular force in case of solid. And in gas, thermal energy is more. Correct? Yeah. Second, in this chapter, it will be really important. Ki atomicity means what is the number of atom in a given system. Example, in O2, atomicity is 2. In O3, atomicity is 3. Okay. So like this, here if we say O3, here atomicity will be 3. S8, number of atom, 8. C12H22O11, number of atom, 45. Why? Reason is, example, if this molecule will be given to you, and then question will be asked, what will be the atomic mole of this compound? Example, if you have 1 mole of this full sucrose compound, then atomic mole will be 45 because there are 45 atoms. Understood? Any doubt?
No, sir.
Uh, So, example here, I am taking oxygen in the consideration. Though this thing is given in the second chapter, we are doing here only. So, whatever is written in the below, it will be atomic number and above atomic mass. So, A is atomic mass, Z is atomic number. What is atomic mass? Number of proton and number of neutron. What is Z? Number of proton or number of electron in the ground state. Ground state means when there is no charge. Ground state means when there is no charge. You have 3 particle: electron, proton, neutron. Charge on the neutron is charge on the neutron is 0. That's why it is written 0. And I will write what actually it is for. This is charge. This one is mass. And in case of electron, mass is 9.1 into 10 raised to power minus 31 kg. Proton electron charge is exactly same but opposite. You know all these basic thing, but we are just comparing, right? Radhika, compare two proton. Will you consider the charge, sorry, mass of electron? Compare to proton, will you consider the mass of the electron? Radhika,
Sir, yes.
answer is no. Why? Because it is almost 2000 times less than proton. It is almost 2000 times less than proton, so you will neglect the mass of the electron.
Okay, sir.
Okay, it's like proton mass is 1 kg. Sorry, electron mass is 1 kg and proton mass is 2000 kg. So you will neglect 1 kg compared to 2000 kg, right? That's how we do. Here, mass of neutron is maximum, then proton, and then electron. That can be asked. Okay. Then you will say, "Okay, sir, but you wrote proton and neutron exactly same mass." Yes, I wrote. But in reality, there is a very small difference. Like in case of proton, it is 1.672. In case of neutron, 1.674. So negligible difference, but you consider almost same. That's why approximately same. How to calculate the mass of one atom? Easy. What is the number of proton and mass of one proton? Number of neutron, mass of neutron. And now you can see here, I am not considering electron. Why? Negligible mass. Understood? Negligible mass. Okay. So mass of proton and neutron is almost same. That's why I'm taking common number. MP means mass of proton. Then you can check what is the proton and neutron. It is simply what is the mass of proton and what is atomic mass. Example. Example. If you take carbon 12, what will be the mass? Mass of atom. Then what is the number of proton and neutron? Total 12. What is the mass of proton? 1.67 into 10 raised to power minus 27 kg. Then you will get the 1 AMU. Understood? Any doubt? Any doubt? So this is important, and focus how to calculate the mass of one atom. Simply, what is the atomic mass A and what is the mass of proton which is fixed. This value is always 1.67 into 10 raised to power minus 27 kg. Correct? Anvita, what is isotope?
Sir,
Anvita, what is isotope?
sir, it's like protons is same, but neutron number is different. Like basically atomic number is same.
Isotope when atomic number is same but atomic mass is different. Example here. In every situation, carbon have six atomic number, right? Carbon have six atomic number in every situation, but atomic mass is different. So these are the isotope of carbon. Same, hydrogen, deuterium, and tritium will have exactly same atomic number. Hydrogen, deuterium, and tritium. They have same atomic number, but atomic mass is different. Correct? So in that case, this is neat question. Chemical property is same, but physical property are different. Why? Carbon 12 is one of the like hard material, but carbon 14 is radio isotope, radioactive material. So physical property are different. And having
So,
yes,
I have a doubt regarding hydrogen, deuterium, and tritium.
hmm.
So, I remember reading somewhere that tritium is used in nuclear reactors, and it's because it has that property.
No, no,
So,
no. We don't use light isotope. Tritium is radioisotope. Tritium
okay,
is radioisotope, so it is radioactive. Example, this tritium is radioisotope heavy form. Carbon 14 is heavy form, so they are radioactive. But you will see very heavy material like uranium are used in case of nuclear reactor. Very
okay,
heavy
sir.
material.
So the
Very,
radioactive property will be considered as a chemical property or a physical property?
it is physical property because there is a physical breakdown.
Okay, sir, understood.
Yeah. You know, we calculate average atomic mass. How? What is the percentage of this atom multiply by the atomic mass and 100? How? Example, if you have boron 10 and boron 11, there are two isotopes. Okay, this is 85% and this is, let's take 15%. Then how to calculate? You will take abundance 85 multiply by 10 plus 11 multiply by 15 like this, divide by 100. Understood? And then you will get percentage. It will be, I'm just taking random number. This is how you calculate average atomic mass. Chandana, what is isobar? These are the basic things, that's why I'm asking. Chandana,
Yes, sir.
what is isobar?
So the compound which has same atomic mass but differ in atomic number.
Yes, atomic number is different and atomic mass is same. So you know when atomic mass is same, that is known as isobar. Atomic mass same. Okay. And what is isoton pratigya?
Same number of neutrons.
Same number of neutron.
Neutrons.
Barinder, what is the isostar? Atom that have same atomicity and same number of electrons. Same atomicity and same number of electron, isostar. In mole concept chapter, you know 1 mole is equal to 6 into 10 raised to power 23. This is Avogadro number. Also, they use symbol Na. Correct? Whenever you take mass of one atom, it is taken in the AMU form. And if you take mass of 1 mole atom, then it taken in the gram. Usually you take in the gram, right? Oxygen 16 gram, H2O 18 gram, carbon 12 gram. That is for 1 mole, not for one atom. Correct? So both are different things. Example for oxygen. Here you have 16 atomic mass. So it is 16 AMU for one atom and 16 gram for 1 mole. Correct? And only 16 for relative atomic mass. Relative atomic mass means compared to other. Relative atomic mass means compared to other. Okay. If you use anything like gram in the beginning or only G word, this simply means it is signifying the mole. Example, 2 gram atom of oxygen, 2 gram, 2 mole of oxygen. Okay, we'll solve a lot of questions, don't worry. These are the very basic thing we do in a mole concept. I hope all of you are aware about this thing. That's why I am making slightly fun. Mole is equal to given weight by molar mass or given number of atom by Avogadro number, given volume by 22.4 liter, or in ml 22,400 ml, or 1 ml is equal to 1 centimeter cube. I will write here 1 ml is equal to 1 centimeter cube. Okay, this thing is important. According to the old STP system, most of time we take old STP system 0 degree Celsius and 1 atmospheric pressure. You did in the kinetic theory of gas chapter also, right? This is the volume we take 22.4 liter. But in new standard, pressure is 1 bar, not 1 atmosphere. So volume will slightly change, but still in most of the calculation you use 22.4. Don't worry. What is the vapor density? Uh, who is left? Jordan. What is vapor density?
So, when there's a mixture of gases, the
Uh,
density of one pure gas in the mixture of gases is vapor density.
vapor density. What is the density of a gas with respect to hydrogen?
Okay, with respect to
Density of gas
hydrogen.
with respect to hydrogen.
Hydrogen.
Okay. In this situation, temperature and pressure should be same. Only then we calculate this. And whatever mass is given for a given gas, hydrogen mass will be 2 gram, right? So you can compare in this. Okay, so if you want to calculate density, you can take density of a gas with respect to the density of the hydrogen. Because temperature and pressure is same, volume will also be same. Then you can take mass only. Though in your normal very first classes, teacher must have taken very long time to explain law of conservation of mass. But now it's not really important for NEET, to be honest. It like question can be asked. I'm not saying ki they cannot ask question, but it will be very easy. Lavoisier was the person who explained this, and it say during a reaction, total mass of reactant will be equal to total mass of product. Total mass of reactant will be equal to total mass of product. How? Example, if you take carbon, which is 12 gram, oxygen, 1 oxygen 16, so 2 oxygen 32 gram. If it makes CO2, mass will be 44. So 12 plus 32 will be 44. So mass of reactant is equal to mass of product. Understood?
So,
Any doubt? Yeah.
so will nuclear fissions and fusions be exempted from this rule?
Nuclear fusion and fission is like, then it will convert into some energy form. That is the thing.
Because they
Mass
said
is
that
different,
mass is conserved. That's why I was asking, sir. Because it's
yeah,
transformed into energy.
if
That's
you
why.
consider only mass, then it is accepted. But
Okay,
you
sir.
know, according to Einstein equation, E is equal to
8
mc
mc
square.
square. Yes, sir.
So mass can get converted into energy, energy can get converted into mass.
Okay, sir.
Okay, so no doubt there is an exemption, but if you consider energy and mass interchangeable in each other, then you will understand this. Law of multiple proportion. It simply says that if you have two elements A and B, they are present in ratio. Example, nitrogen. You can take nitrogen oxide. You can take NO2. You can take NO3. Right? Here, nitrogen is fixed and oxygen is increasing by 1. So they will be present in ratio. That is the simplest meaning of multiple proportion given by, what is the name of this guy who gave atomic theory? Dalton. Dalton explained this thing, law of multiple proportion. Okay, and last is law of equal proportion. It simply says that whether you take artificial material or you take natural material, composition will be same. It means if you take artificial water or natural water, both water will have H2O. As simple as that. This is also known as law of definite proportion. Law of equal proportion or law of definite proportion. Okay, I think this was given by Proust, what I can recall. Right? Proust, I guess, something like. You
So
already know about the Gay-Lussac law, which says that. Yes, Anvita.
no, I was just saying that Sanya like asked me to inform you that she has a class, so that's why she's not joining.
Okay, no issue. We'll record the session. Like I'm recording the session, that's why I'll update it soon.
Yeah.
Okay. Gay-Lussac law. Who will tell me Gay-Lussac law? Because we did this in the other chapter, like KTG. Uh, Radhika, what is Gay-Lussac law?
Sir, it tells us about the relationship between like the pressure and the temperature of gases at constant volume.
At constant volume? No.
Yes, sir.
Uh, who else will tell? Chandana. Know the exact answer. They're very close. Chandana, what is Gay-Lussac
Yes,
law?
sir.
What is Gay-Lussac law?
So pressure is directly temperature.
See, there is a Boyle's law where P inversely proportional to V, pressure inversely proportional to volume. Correct? Just give me a minute. Okay. So when pressure and temperature is same, then volume is directly proportional to number of mole. Understood? When pressure and temperature is same, then volume is directly proportional to the number of moles. Example, here you have moles, like here you have 1 mole and 2 moles, right? So volume you can take in the same ratio, 22.4 liter, 22.4 liter and 44.8 liter. Understood, guys? Okay. Any doubt? Gay-Lussac law says that when pressure and
Yes.
temperature is constant, volume is directly proportional to the number of moles. More number of moles, more volume. And same thing here. These things are moles. These are moles. Correct? And more moles means more volume. Now, after that, this was just basic introduction part. Now you are getting the real content of mole concept. First, most important is empirical formula. Pratigya, what is empirical formula?
मतलब कोई भी फॉर्मूला को सिंपल रेशियो में कन्वर्ट करना.
Exactly. कोई भी formula का simple ratio. अब मान लो we have this glucose. Glucose formula is C6H12O6. This glucose, if you divide by a common number 6, the simplest ratio will be this. So this is empirical formula. Real formula is molecular formula. Okay. Whatever is the real formula of the compound, it is known as the molecular formula. Any doubt, guys?
No.
No, sir.
Yeah. So molecular formula, real one. Empirical formula, exact one. Okay. And in this case, we take consider multiplication factor. Multiplication factor by which number you are multiplying to get the real number. Example, in this situation, you know molecular formula is exact. Empirical formula is the simple whole ratio. So what is the n? In this case, n is 6. Correct. How to get it? First thing, percentage of each compound will be given. Example, carbon percentage given, hydrogen percentage and oxygen percentage. Then you will divide with the atomic mass of this atom. And whatever number you get, this will be present in the simple whole ratio. So here you can write C4H4O3. I just took random number. Okay. Any doubt? Next, what should be the minimum
No,
molecular mass? Yes, Radhika. Hello. Hello. Am I audible?
Yes, sir, you are audible.
Radhika, do you have network issue?
No, sir.
Okay, you were asking something?
Sir, I didn't ask anything.
Okay. Anybody ask something? Okay, no question. What should be the minimum molecular mass of the compound? What is the atomic mass divided by the what is the percentage of the element? That you will do in the particular question, and we will solve each and every type of question. Next, what is weight by weight situation? Because you most of you are done with the solution chapter, same thing are given there. You have to know what it means. It means if you have a solution, 20 grams is anywhere. With the amount what Hello guys, am I audible?
Yes, sir.
Huh. So, Barinder, I asked you a question. Ki in this situation, if 20% weight by weight NaOH given in aqueous solution, 20 gram is NaOH, total mass is 100 gram of the solution. Tell me what should be the amount of solvent?
80.
80. And what is the solvent name in this situation? What is the solvent name in this situation? Water. How do I know water is this? Aqueous solution means water is the solvent. Understood? Aqueous solution means water is the solvent. And whenever you take any solution, you have two components there, solute and solvent. Example, if you dissolve sugar in water, water is present in large amount, so water is solvent. Sugar is solute. Mixture of these two is known as solution. Same thing is present in the volume form, volume by volume, and weight by volume means given mass of the solute divided by volume of the solution. This is solution. This is solution volume. Any doubt, guys? And here, example, you have one mole. Who is missing? Yeah. Am I audible to everyone?
Yes, sir.
Yes, sir.
Okay. And remember, when we are doing lot of theory together, I can't tell you story, so you will feel bored for sure. I'm telling you, even because I can feel it personally. Okay. But because we have to make it fast, we don't have choice. Understood? That's why it will be boring now, but once you will start solving question and you will be able to solve, you will enjoy the process. How many of you are feeling bored now? Is that what is happening? What is going? How many of you are bored? Because I am personally bored
No,
in this topic.
sir.
Barinder. Anybody else?
No, sir.
Okay, good,
No, sir.
good. So the point is ki, why I'm bored? Because my way of teaching is to tell lot of story, lot of logic and the stuff. But why it could be boring for some people? Because we can't tell story. Reason, we don't have time. Okay, we want to finish full syllabus on time, and at the same time we want to solve more numerical. That's why we have to do like this. Okay, come to this part, purity concept. Purity concept is applicable only for reactant, not for product. Yield is applicable for the product. What is the yield of the reaction? What is the quantity we get from the reaction? It means we are talking about product. And pure, whether you are taking pure compound or impure compound in the reaction, it is about the reactant. So how to calculate mass of the reactant? So what is the mass of the pure reactant and what is impurity? Example, you have 100-gram material. Out of this 100-gram material, example, 100-gram gold, 90 gram is pure gold and 10 gram is copper or other material impurity. Make sense? This is how we calculate. What is the total amount of the substance? Pure compound plus impurity. So how to calculate purity? What is the mass of the pure reactant? In this case, 90 gram. What is the reactant mass? 100 gram and multiply with 100. So if you do this, what will be the purity of gold in this situation? What will be the purity of gold? 90%. How we get to know? Mass of the pure substance, 90 gram. Mass of the total substance, 100 gram. Multiply by 100. 90 divided by 100 multiply by 100, you will get purity, 90%. Understood? Even you can calculate here impurity. What is the percentage of impurity? So mass of impurity divide by total reactant mass multiply by 100. So Jordan, what will be the impurity percentage in this situation?
10%.
10%, exactly. Example, we usually have 24 carat pure gold, right?
Yes, sir.
This is pure gold. But usually whatever jewelry you use, it is 22 carat gold. It means out of 24, 22 is gold and 2 is impurity. How to calculate purity in this situation? Amount of pure gold 22, total 24 multiply by 100. You can calculate percentage of purity. Understood? In case of impurity, it will be 2 by 24. Make sense, guys?
Yes, sir.
Yield. Yield means product. What is the actual yield produce and what is the theoretical yield produce? Multiply by percentage. Example, theoretically, you should produce 100 gram of gold, but in reality, you have only 92 gram of gold. What is the yield of the gold? 92 actual divided by 100 multiply by 100, 92% yield, not 100%. Understood? And how to calculate yield in this case? You need limiting reagent. Tell me, guys, how many of you face problem in limiting reagent?
Sir, I get confused.
You get confused.
Me too, sir.
Pratigya? Okay.
Yes.
Pratigya, I think one of the challenge student face in this whole chapter is mostly limiting reagent. Correct? Usually this chapter is easy for people, but limiting reagent is one. Why? Because for this you should have proper data. Chandana, do you face issue?
Yes, sir.
Okay. So limiting reagent, here we discuss only about the reactant. Which reactant will consume first in the reaction is the limiting reagent. This limiting reagent will decide what will be the amount of product. Okay. If somebody just give you reaction, example 1 and 2 react with 3 mole of hydrogen and produce 2 mole of ammonia. Here you cannot tell which is the limiting reagent. You need data. Understood? You need data. Just based on this reaction nobody can tell. Come to the point. Example, if you take 10 mole of nitrogen, according to this there should be 30 mole of hydrogen because triple. If you take 1 mole of this, then you should require 3 mole of the hydrogen. But if you take 10 mole of this, then here you need 30 mole. But according to the situation it is given, you have only 10 mole. Can we say we have shortage of hydrogen? And that is the reason we need 30, but we have only 10. That's why it is a limiting reason. If we need more, but it is less. Okay. So if hydrogen is a limiting reagent, nitrogen is excess. How do we know? If you have 10 mole of hydrogen, nitrogen should be 1/3 because here it is 3, here 1/3. It should be 3 mole, but you are having 10 mole of nitrogen. It means it is a excess reagent. Understood? So based on the data, whatever will be given to you, only then you can tell. Mole fraction. You know what is mole? Ratio of a given mole divided by total number of moles. Example, Na is the mole of the solute. Nb is the mole of the solvent. And Na plus Nb is the mole of the solution. So how to calculate mole fraction? Given mole divided by the moles of the solution. Same for B. Given mole of the solution. If you add both of them, you know number will be 1. I think we are in the end of the chapter. Chapter is almost done. Wow, yes, it is done. I'll make summary of this chapter, like what is required, but most of the thing is done. Molarity. Molarity is also known as concentration. If you use word molarity or you use term concentration, it is the same thing. I will write here concentration. Both are the same thing, concentration or molarity. Okay. It is what is the number of solute mole present in 1 liter of solution? You know what is more important? Solute mole, volume of the solution. Because if you write solvent here, it will be wrong. Okay. So this is the mole given mass by molar mass. And here, when you take volume in ml, then you will take 1000. You know that mathematically. And that's why unit of the molarity or concentration is mole per liter. Solute mole and solution volume liter mole per. For ionic compound, if you have instead of normal solution, you use term formality, but exactly same thing. Normality and formality are the same thing, but only for ionic compound. If you dilute the solution or you concentrate it, you know number of mole will be constant. Number of mole will be constant. And if number of mole is constant, you know molarity is equal to number of mole per unit volume. So what will be the value of number of mole? Molarity into volume, right? And number of mole is fixed if you dilute or concentrate. That's why you had this. Tell me guys, all of you had idea कि we use M1 V1 is equal to M2 V2. Were you 100% sure because number of moles are constant if you dilute or concentrate? Because amount will remain same. Example, if you take 50 gram of sugar in 1 liter of water, and now if you change the water content, it will dilute the solution or concentrate the solution, but amount of sugar will be only 50 gram. It is fixed. That's why number of moles of solute are also fixed. Understood? Number of moles of solute are also fixed. What is the molality? Same thing, but in 1 kg of solvent. Same like molarity, but in 1 kg of solvent. And you would use molal. Here you use term molar. M-O-L-A-R. Molarity, molar. Molality. Okay. You can write this in the mole fraction form. So I wrote mole fraction form, but as of now, it's not really important. What is the strength of the solution? What is solute mass? Not moles. Mass in 1 liter of solution. Mass in 1 liter of solution, not moles. Okay, mass in 1 liter of solution. Okay. And you know, now we will not do this, and everything is done. So, what is the most important part in this chapter according to NCERT? Let me quickly revise.
Sir, I have one doubt in NCERT question of delimiting reagent.
Definitely, I'll take NCERT out. Okay.
Okay, sir.
So, in this chapter, we know uh, it talk about the mole. A mole could be given weight by molar mass or number of atom by Avogadro number, or it could be given volume by 22.4 liter. One thing, number of moles. Second, if you take one atom mass, then it will be given in AMU. But if you take one mole mass, it will be given in gram. Understood? Next, when you understand this, two things. Standard temperature pressure, what is STP? STP say that कि if you have 0 degree Celsius temperature and 1 atmospheric pressure, it is standard temperature. Okay. Then you have empirical formula, the simplest whole ratio. Simplest whole ratio. Then you have molecular formula, exact ratio, exact whatever is given. And if you correlate, molecular formula will be n time of empirical formula. N time of the empirical formula. Okay. You have vapor density. Vapor density is molecular formula divided by 2 because we compare with the hydrogen. Divide by 2 because we compare with the hydrogen. All the mass you will take with compared to 1 AMU. 1 AMU is the how many times mass is heavier compared to 1/12 mass of carbon 12 isotope. You must have heard this, right? If you take carbon 12 isotope and divide by 12, it will be equal to 1 AMU. How to calculate 1 AMU, like mass of atom? The simplest version is what is the atomic mass multiply by what is the mass of one proton? 1.67 to 10 raised to power minus 27 kg. Okay. Next, you have different laws. First is a law of conservation of mass given by Lavoisier, and he said कि mass of reactant and product remains same. Second, law of definite proportion or equal proportion. He said whether you take artificial thing or natural thing, content will remain same. Like if you take natural water or artificial water, content will remain same. Law of multiple proportion. Multiple things will be present in the right proportion. Example, if you take NO, NO2, NO3, they here oxygen is present in the simple whole ratio. Gay-Lussac law, which says that the volume directly proportional to the number of mole if pressure and temperature are constant. Pressure and temperature are constant. Okay. All major law is done. After that, you have different type of form like mass weight by weight. Weight by weight. Given weight of a material by total weight of solution multiply by 100. So this weight by weight percentage. Volume by volume, same method. Weight by volume, as the name suggests, given weight by total volume. Right? Done. If you take ratio of moles, then you get mole fraction. So mole fraction is represented with the x. If you say XA, number of moles of A, total number of moles. Same for B. And addition of A and B will be 1 always. So no need to calculate both, calculate 1 and then minus from the 1. Okay. After that, you have limiting reagent. Very, very, very important. Limiting reagent means agent that is present in less amount. And when it is present in the less amount, it will decide product amount. It will decide product amount. Okay, how to decide? Check what should be the limit. Example, what we have seen ki in case of N2, react with 3H2, form 2 ammonia. If you take 1 mole of this, it should be 3. If you take 10 mole of this, it should be 30. But according to the question, only 10 moles are given. Can we say this is limiting reagent? Understood? It will be given in the question. In nitrogen and hydrogen molar 10, 10. It means it should be 30, it is less. Then you have molarity or concentration, which is given number of mole per unit volume of solution in liter. Molality, given number of moles, mass of the solvent, mass of the solvent. I will add a normality also, and normality, number of gram equivalent, number of gram equivalent per unit volume. Okay, and this normality n is simply equal to valence factor multiplied by the molarity. Also, out of these three, only this molality does not depend upon the temperature. Only this. Only this does not depend on temperature. Why? Because volume is not included. And you know, whenever temperature is changed, volume will change, and your all the molarity, normality, everything will change. Okay, everything will change except molality. So it is a good way. If you want to calculate, you should use molality. Okay, and anything we missed from this chapter? I don't think so. Strength. In case of strength, it is almost equal to molarity, but instead of the moles, you take mass. Mass of solute divided by volume. Almost look like molarity, but now, guys, we are done with the theoretical part, and you know, it's just introduction. Now we can solve any question. And yes, Radhika, ask me your question. NCERT question, no? Chemistry, part 1.
So towards the end of the class, can you explain isostars once again?
Yes. Where is the question? Significant number we usually do in the unit and measurement. Okay. And by the way, all these things are given, like Robert Proust, given the definite proportion and multiple proportion given by Dalton, Avogadro law, you know, same number of atoms, Dalton atomic theory, key, all the material made up of atom, atomic mass, what should be the atomic mass, what is AMU, mass of one atom, average mass, formula mass, mole concept, percentage composition, empirical formula, stoichiometry, very important limiting reagent,
I have GOC doubt.
GOC doubt. GOC doubt. Yes, we'll solve GOC doubt. Where is the limiting reagent? Which question you were talking about?
Sir, I was
Yeah.
talking about 1.5. Yeah, this question
Okay.
only 1.5. Because they explained it in a lengthy way, so it's confusing.
Yes, it is confusing. Let me do it. Yes, yeah, बोलते हैं. Pratigya will solve this GOC doubt in the end of this session only. So, you know, nitrogen react with 3 mole of hydrogen and produce 2 mole of ammonia, right? You can write this in the
Yes, sir.
multiple way. Here, let's take 1 mole. You can write in the moles, like if you take 1 mole of this, it should be 3 mole and it should be 2 mole. Correct? If you write in the gram, if you take 1 mole, so it is 28 gram. This should be 3 moles, 6 gram, right? And this is 14 plus 3, 17, 34 gram.
Sir,
You
but
can
like
take
while
the
writing this, mainly when we'll form equations, means what in our college they studies that always we should balance the equation.
yeah. I wrote the balance equation. Example, here you have two nitrogen,
Yeah.
six
Means
hydrogen,
without
three to one.
balancing we cannot proceed with reaction, no, sir?
That's true. That's true.
Okay, sir.
We cannot do the reaction without balancing. That's why balancing is must. And we learn balancing from the redox reaction chapter, right?
Yes, sir. Okay, sir.
Now,
Understood.
what you have to do, guys, just calculate number of moles of nitrogen and number of mole of hydrogen and check which one is limiting reagent. Example, in this situation, if you take 50 gram of nitrogen, so can you say 50,000 gram multiply what is the molar mass of nitrogen? 28. Here, 10,000. What is the molar mass of hydrogen? 2. Correct. We can calculate number of moles. Here, you have 5,000 moles. Correct. You have 5,000 mole. What is the number of moles in this case? Maybe approximately 1, if you take 1.8, 1800 moles. Something like that, I guess, right? Is it correct? You can take ratio 50,
So
20,
I get
70,
1785.
Yeah,
1.7,
1787, 85.7.
1,
Yes, sir.
1.7, okay, 1785.
85.7.
Okay, so I'm taking it approximately 1800. So tell me, logically, if you take 1 mole of nitrogen, it should be 3 mole. If you are taking 1800 mole, it should be 5400, 3 times, right?
Yes, sir.
But you have only 5000. It means what happened in this situation? This is less, and less is limiting reagent. Tell me, Radhika, was it really difficult?
No, sir.
Done. So what to
So,
do? First calculate mole and see what should be the mole. Yes,
yes, sir.
Radhika.
So the next part I am facing difficulty.
Which part? Calculate the amount
Calculate
of
the
the
amount
ammonia.
of, yeah.
Only limiting reagent will decide the ammonia, not the axis. So hydrogen will decide what will be the moles of the ammonia. It means if you take 3 mole of hydrogen, then you produce 2 mole of ammonia. If you take 5000 mole of hydrogen, how many moles will be produced? 2 divide by 3 multiply by 5000, right? So
Yes,
10,000
sir.
divided by 3. This number of moles is produced. Amount, moles are is equal to given weight by molar mass. Molar mass is 17. Multiply this with 17, you will get answer. Okay, multiply
Okay, sir.
this with 17, you will get answer. Done.
So can you
Yes, sir.
explain this last part, sir?
Say yeah, sure. So Jordan, according to this situation, I said ki only limiting reagent will decide the amount of product. Only limiting reagent. So in
Yes,
this
sir.
case, hydrogen will decide what will be the amount of ammonia, not nitrogen. You know, 3 mole of hydrogen produce 2 mole of ammonia. So one unitary method, 1 mole will produce 2 by 3, and 5,000 mole of hydrogen will produce, take this, understood? So this will be the number of moles of ammonia, moles. But we need amount, not mole. What you do? Formula to calculate moles is given weight divided by molar mass. Correct? Given weight divided by molar mass. If you want to calculate amount, number of moles multiply by mass. Moles you already have 2 by 3, 5,000 this. So 10,000 by 3.
which is
Multiply by mass.
3,333. It will go on in threes. So, but the 17 part, okay, understood now.
Molar mass of ammonia.
Molar mass, understood. Yes, sir, yes, sir.
Radhika,
Okay,
was it
now,
really lengthy?
हाँ सर समझ आ गया.
Jordan, any doubt?
no, sir.
Guys, tell me, anybody have doubt from this chapter? Let me know. I'll finish right now.
So the isosters part,
Give me a minute. Yes. Tell me, Jordan, you were asking something.
so the isosters part, sir.
Yeah, isoster part, in the notes, it is the total number of atom remains same. One thing. And second is total number of valence electron remains same. If two element have total number of valence electron and atomicity, then it is isostate. Total number of valence electron. Same valence electron. Got it?
Sir, I think like isosters, another name is isoelectrons, right, sir? Isoelectric species, like having the
No,
ions and
only valence
charge.
electron. Only valence electron. Example, the valence electron in case of magnesium and calcium is 2, right? They have
Okay,
different atomic number, but valence electron is 2. And their atomicity usually in calcium carbonate or magnesium carbonate, it will be 1. So they are isosters, right?
okay, sir.
Yeah. Guys, if you don't have any doubt now, we can proceed to the question.
So one more
Yes.
doubt. So
Yes.
isosters would be, for example, group one, whatever elements, then group one will be isosters to each other. And
Yeah,
isoelectronic
every
species,
element will be like isoster.
okay, and isoelectronic meaning electrons
Same
overall
number
in
of
all the cell.
electrons. Same
Total
number
number.
of
Oh,
electrons.
okay, sir.
Yeah. So guys, with this we are done with the chapter. Even if you need summary, majority of things are done in the last part. This part. This cover majority of the thing. This thing. Okay. But without question, every chapter is incomplete. So we can directly move to the PYQ and see what examiner is asking. Chapter wise chemistry, some basic concept of chemistry. See here in 2025 they asked really good question. Dalton atomic, uh, yeah, this NCERT will go, no problem. We'll save this PDF. And So Dalton atomic theory could not explain which of the following thing. What is your answer, guys?
Option B is the
Because you saw it, but why?
not because I saw it, because I remember from this just paper. I just
Sir,
remember answer
because
key.
like law of gaseous volume was means it was given by
Gay Lussac.
not Dalton. Yeah, Lewis. It was
Mhm.
given by him.
It was given by Gay Lussac, right?
Yeah.
Not by Dalton. No, no. But it is asking which is not explained by the Dalton atomic theory. Because first three law of conservation of mass, law of uh, definite proportion, and law of multiple proportion. These three were the law of chemical combination. Together, they are now law of chemical combination. And all the chemical combination law were given by the Dalton, explained by the Dalton atomic theory. Understood? Now, because this is the one thing we can add in our notes as well. Uh, Here also, these three law of conservation of mass, definite proportion, and multiple proportion are together known as chemical composition. The composition of the chemical remains same, right? Composition, whether it in the form of amount, whether it in the right proportion, or whether in the form of mass. Any doubt, guys?
No, sir.
Yeah. Next, every year, and Chandana, Anvita, and Jordan, tell me, I told you every year they are asking question. Even in 2025, they asked question from this part. Every single year, NEET is asking this kind of question.
Yes, sir.
And I told you before NEET exam, right? You will
Yes, sir.
100% question. 100%. And same thing happens. And see, it's not like I am predicting it, I'm the best. No, it's just because I can see the pattern. Every year they are asking almost. So here you have to check what is the equal number of atoms. For equal number of atom, number of moles should be same, right? Here, what what will be the number of moles in this case? 2. What is the number of atom? 2 plus 1 plus 3. 6. Make sense? Understood? I told you atomicity is really, really important. What is the number of atom? Here number of atom is 6. So whatever will be the number of mole, you will multiply with the 6. 2 more. What is the number of moles here, Anvita?
4.
4. But what will be the number of moles in the atomicity? 12.
Sir. Yeah.
In the first case, number of mole is 2. Atomicity is 6. So it is also 12. Third case, Pratigya, what is the number of moles? Pratigya, what is the number
तो
of moles?
40 by NaOH का तो 60
6.
60 मोल 6
240
हाँ
by
6 मोल
40. It is written
हाँ
here,
6
right? What will be the total number of
हाँ
atomic mole?
40
18. Why? Sodium is one atom, oxygen is one atom, hydrogen is one atom. What is the total number of atom? 3. Chandana, in this, what will be the number of moles?
6,
And what will be the atomic mole?
2,
6 multiplied by 2, so 12. Why? 2 hydrogen. atoms, but we are talking about number of atomic mole. And I told you in the notes, it is about the atoms mole. Remember, it is about the atomic mole. It is about the atomic mole, not just mole, atomic mole. Where I said 1 mole atom, gram atom, 16 AMU, atomic mole. I told you somewhere. Where was this? Gram atom. Yeah, gram atoms means number of moles of oxygen. I told you one more is atomic mole. If it is not given, I am damn sure I told you, but still, if you are asked to check atomic mole, what you will do? What is the number of mole? Multiply by atomicity. Okay. Example, in this question, there was 212 gram of Na2CO3, right? First option. And molar mass was 106 gram. This is molar mass. How to calculate? Number of moles are 2. What is the number of atomicity? 6. How? 2 sodium, 1 carbon and 3 oxygen. Total 6 atom. What will be the atomic mole? 12. Understood? Everybody understood?
Yes, sir.
So
Yes, sir.
this is the formula. Atomic mole are the, what is the number of mole and then number of atom in that molecule. Number of atom. Are we left with any option? Yes. Hello guys, what happened?
So I left the meeting.
I will do some. See, Marinder, what is the number of moles in E option?
5.
What is the number? This is 5. What is the atomic mole in this?
15.
15, because there are 3 atoms. Now you have to tell where you have equal number of moles. Here you have 12, 12 and 12. Tell me, in A, B, D number of moles are same? 12, 12 and 12. Check whether you have ABD in the option. Do you have ABD in option? And tell me guys, was it really difficult? Even
No, sir.
2025 NEET question. Arey, 2025 NEET question, was it really difficult?
No, sir.
But at the same time, I understand the because of the lengthy nature of the overall biology and physics, we can't target student. Oh no, you could not solve this question. Understood? Next, Radhika. Amount of glucose required. Amount of glucose required to prepare this. What is the molarity? 1 by 20.
1 by 20.
Molarity is 1/20. You have to calculate given weight.
We have to calculate the weight of it.
Yes, how to do? You know, formula of molarity is given weight by molar mass,
Yes.
1000, and volume in ml. Always
Yes, sir.
write in ml, otherwise you will be confused. Now all the values are given. Molarity is 1/20. Given weight we have to calculate. Molar mass 180, 1000, volume 250, 4, 45. So what will be the weight? 45 by 20. 22.5 divided by 10, so 2.25 gram. Was it really difficult? Direct
No,
formula
sir.
based question. Okay, so it just simply you have to apply NCERT formula. Next, Chandana, same question. Uh, Tell me, what is the number of molecule present in this 1 gram? You have to check moles. If you have same number of moles, same number of molecule will be there, right? If same mole, same molecule will be there. Example, in the first situation, in hydrogen, what is the number of moles? Given weight 1, molar mass of hydrogen 2, 1/2. What will be the mass here? Given weight 14, molar mass, Chandana,
28.
28. So 1/2 definitely is the answer. Chandana, what is the molar mass in this case? 18, 1
18.
mole. In third, tell me fast.
28.
28, it is not same as 1/2. And fourth, 28 gram,
1.
1. So now you can check wherever you have half mole, this is the answer. This is the answer.
Yes.
This is not given in our chapter. Jordan, sixth question.
So they're asking us to find limiting reagent.
Yes.
1 minute, I'll solve it.
All of you have to solve every question. It's not like if person have question, you are not supposed to solve it. You have to.
So
Yes, Jordan.
I get 250 milligrams.
You get 250 milligram.
Yes, option B, I think.
Okay. So, oh, have issue. Why there are less people? Anvita is not there.
Sir, can you show that question once?
Yeah. 1 gram of NaOH was treated with 25 this of HCl. What will be the mass of NaOH left unreacted? Now you have to see what is the limiting reagent in this question. Limiting reagent. So you know when NaOH react with HCl solution, what will be the product? Product will be NaCl and H2O. Correct? It means if you have 1 mole of this 1 mole will form. Right? If you have 2 hydrogen balance, 1 oxygen balance, 1 chlorine balance. And everything is already balanced. It means I think I have to buy the bigger plan. I'll check today if I have to buy bigger plan, so nobody face issue in this. Even we can choose Google Meet, but I think there we cannot um, this record the session, right?
You can, sir.
We can. Then
Yeah,
I'll check.
my sister's school used to do it for them.
Okay. So in this case, NaOH react with HCl and produce NaCl and H2. This is the question. Here, if you take 1 mole of this, then 1 mole of this react and form 1 mole of this. It means if you take 40 gram of this, then 36.5 gram of this will produce how much? 58.5 gram. Because I took gram. Mass, gram. If you understood this, now you have to first calculate what is the amount of HCl, molarity. Molarity formula is given weight by molar mass 1000 by volume in ml. What is the molarity? 0.75. What is the molar mass? 36.5 for HCl. What is the volume? 25. It will become 40. Okay, so what will be the weight? 0.75 multiplied by 36.5. Sorry, multiply by 36.5 divide by 40, you will get the weight. Okay, to make it easy you can take mole also. Mole will be easier process. How? Calculate mole of HCl and you can solve question how. Example, molarity is 0.75 gram. Number of, if we calculate, and what is the volume of the solution? 25 multiply by 1000, 40. Number of mole will be 0.75 divided by 40. Okay, you can calculate number of moles also. What is the number of moles of NaOH? 1 by 40. What is the number of moles of HCl? What is the number of moles of HCl? This is 3 by 4 by 40. Correct. Which value is greater? Which value is greater? NaOH. It means it will be in the excess amount. So number of moles of NaOH should be equal to the number of moles of HCl. Okay, so number of mole of HCl is 3 by 4 multiplied by 40 is equal to same amount of number of moles will be available for the hydroxide. What should be amount if molar mass is 40? You can calculate. Understood? 40, 40 cancel. Weight should be 3 by 4. Weight should be 3 by 4 gram. Will react. How much will not react? 3.4 means 750 milligram will react. How much will not react? 250 milligram. Tell me how many of you did not understand anything, sir, what you were doing?
Sir, I didn't understand.
Who else did not understand anything?
Sir, can you explain the last part?
I will explain full part again. Pratigya, Barinder, Anvita, Jordan.
So I got it, sir.
Okay. See,
Yes,
this is the last. Okay, Barinder. Sorry, Pratigya. So we know if we take 1 mole of HCl, there will be 1 mole of NaOH. Correct? Here you have 1 gram of hydroxide. Can you write this 1 gram as 1000 milligram? Same meaning. One
Yes,
gram
sir.
is equal to 1000 milligram. It is saying the mass of the NaOH is left unreacted. It means NaOH is present in excess and this is present as limiting reagent. Understand? It is asking how much is remain unreacted for NaOH. Understood?
Yes,
So
sir.
whatever will be the number of moles of HCl, same number of mole will be there for the NaOH. When we calculated for number of moles of HCl, how to calculate? Molarity is equal to number of moles divided by volume of solution. And if you take in ml, multiply by 1000. This is the formula of molarity. Any doubt till here?
No, sir.
Molarity is 75 by 100 because 0.75. Volume will go in multiply and volume value is 25. And 1000 will go in denominator. It will become n. And this is equal to 1 by 40. Any doubt, guys?
No,
No,
sir.
sir.
So we know number of moles of HCl is 75 divided by 140, correct? So how
Yes, sir.
many mole of NaOH will react with HCl? Same number of mole. Because if it is 1, HCl is also 1. So what is the number of moles react with the HCl? Same number of mole. How do we know that? Because 1 mole of NaOH react with 1 mole of HCl. Both moles should be exactly same. Understood?
Yes, sir.
So how now you have to calculate it how much amount of NaOH will react with this. So number of moles of NaOH is same as that. HCl mole 75, 100, 40. NaOH mole given mass by molar mass is 40. That molar mass is 40. 40, 40 cancel. Okay, 40, 40 cancel. So what will be the weight? It is 75 by 100. If you multiply both with 110, what will happen? It will become 750 milligram. Instead of gram, you can take milligram. Yes or no, guys? Actually, this was 75 by 100 gram. If you want to convert into milligram, what will you do? 1000 take multiply with 1000, right? 1 gram is equal to 1000 gram. Yes or no? Yes or
Yes, sir.
no? We said, I'll do it again. Our value is 75 by 100. This is the weight of NaOH. And this is given in the gram. If you want to convert into milligram, what will you do? You will multiply with 1000. You will multiply with 1000. 2020 cancel. So what will the weight? 750 milligram is reacting with the 750 milligram is reacting with HCl. What amount is not reacting out of 1000? 250. Yes or no?
Yes, sir. Understood, sir.
Anvita, any doubt?
No, sir, got it.
Barinder,
No, sir.
Pratigya,
No, sir.
so let me give a quick revision what happened in this case. First step, step one, because it look lengthy, we have to summarize this. Step one, calculate HCl moles. Step two, number of HCl mole are exactly same as NaOH mole. Step three, when both moles are same, you can calculate mass of NaOH. And fourth step, you can convert this mass of NaOH from gram to milligram and multiply with 1000. Now it look easy.
Yes, sir.
Then, so that's all, guys. And if you see it in the first instance, you will feel कि sir ये तो बहुत मुश्किल है, it's very tough. But it just if I have to do this, you know what I'll do? If I have to do the same process in fraction of second, I will not do complete calculation. I know there are four options: 750, 250, 0, and C is not possible. 100, 1000 mg we have in this situation. Now I have to check what is the number of moles. The number of moles according to the HCl is the molarity multiplied by volume divided by 1000. So it will be equal to 75 by 100 multiplied by 40. This HCl mole is also equal to the NaOH mole. NaOH mole is 1 by 40. This cancel. You can calculate W amount here. And if you multiply by 1000, 2020 cancel, it will be 750. Tell me how much time I took to finish it. But I'm not expecting from you. I just keep this speed you will get once you solve question from this chapter. That is what I'm trying to convey. Understood? Because in exam you cannot do everything in such detail. Here we are doing to get better understanding. Same question. Anvida, what is the highest number of helium atom? What is the number of moles in this 4 moles? What will be the helium atom? 4 Na, 4 into Avogadro number.
Yes, sir. Yes, sir.
What will be the number of moles in second, Anvita? Anvita,
Um, one. No, wait, no.
yes. Given mass is
Mm.
4, molar mass
Yeah.
4, so 1 mole. Third case. Barinder, what is 4 gram of helium? One mole, so 1 Na. Correct. Next, this 2.27 liter, it is very less. 2.27 divided by 22.7. Okay, divided by 22.7, it's very less. 0.1 mole. Where you will get maximum number of moles? A, right? Because there you have maximum number of moles, 4 mole. Understood? Guys, understood? Here you have 1 mole, 1 atom, 1 mole, and this number of mole very less. Last question of the day. I don't know why. I try to solve less, but every time I do more content. Pratigya, question. A compound X contain 32% A, 20% B, and remaining C. What is the amount of C? A 32, B 20. What is C? This total is 52. Maximum is 100. So 100 minus 52, what is the third amount? 48, guys, right? Yes or no? They will not give third thing. You have to calculate. Total is 100. One is 32. Second is 20. Become 52. Remaining is 48. Now first calculate number of moles. 32. What is the molar mass of A? 64. 1 by 2. Number of moles given mass 20. Molar mass 40. 1 by 2. C. 48. What is the molar mass? 32. It will be 3 by 2 because divide by 16. 16 2 is 32. 16 3 is okay. Can we say this is like 1, 1 and 3 times? You can multiply with the 2, right? So what will be the answer, Pratigya?
B.
Exactly.
B.
अरे क्या गजब आंसर दिया तुमने. You are too good. Okay. तो अब तक कितने लोगों को लग रहा था, as of now, how many of you were thinking that this empirical formula you can do it, but it take very long time? It does not. Okay, same thing, you have to just do it. Remaining thing I will do later. So you have lot of work to do. Almost 30 question of laws of motion. Laws of motion, 30 question. And around 30 question you have to do from mole concept. So that's all for today's class.
So
Can you
laws of
share?
motion में what do we have to do? Revise the chapter.
No. You have to finish full chapter, not revising. All 74
सर रात को
questions.
कितने बजे क्लास होगा?
कोई क्लास नहीं होगा अब. No class.
So can you give a task for bio too?
Tomorrow we'll do biology because we have done this chapter. So you have to solve minimum 30 questions. Otherwise, you won't understand this chapter perfectly.
Okay.
30 question of mole concept and remaining question of laws of motion.
Okay.
Tell me, guys, was mole concept really a long chapter?
No, sir.
And how much time they take to finish this chapter? Anvita, तुम्हारा कितना लिया था एलन में?
So they were already done with this chapter, so I don't know. But I think 11th में they took a lot of time, if I remember correctly.
11, they took a lot of time. Jordan, for you in this Palas?
I think they took 1.5 weeks, but that was when I didn't join it yet. They finished the chapter before I joined.
Okay, but they took 1.5 week,
Yeah.
almost 10 days.
Yeah, more or less.
And okay, and this Radhika,
Sir, for us, they took some 3 to 4 days only.
full chapter only 3 to 4 days.
Yes, sir.
Seriously, you are in 11th
Yes,
class
sir.
right now, or you are preparing for NEET, like dropper batch
No, sir. I am in 11th class.
right now?
Yes, sir.
Okay, only 3 4 days in 11th class. Seriously?
Yes, sir.
Okay, wow, you are lucky. But do you guys think more than 2 class is not required for this chapter? One, theoretical basic understanding, and second, question, especially for the repeater. I'm not talking about the 11th class, but at least for repeater, right? Yes or no, guys?
Yes, sir.
प्रतीक, तुम्हारा कितना टाइम लिया था सर ने जब एसपीएम में तुमने स्टार्ट किया था इस चैप्टर से?
कम से कम 10-15 दिन तो लगा था।
10-15 दिन। हाँ, तो यू विल ऑलवेज थिंक कि इतना टाइम जो लग रहा है ना, हम बहुत कम टाइम लगाए. एटॉमिक स्ट्रक्चर 2 class. We will start directly with the quantum number first, and we'll finish this topic of quantum number, and second remaining chapter. So 2 class. Okay, only 2 class. 1 class for periodic classification. देख रहे हो कैसे धनाधन काम होगा? Are you seeing how fastly we are growing? And it's not like we are making it too fast. It's just you have to solve question. Okay.
Yes.
Okay. Yeah. So finish this portion by tonight. Tonight, whenever you sleep, you need, trust me, minimum 2 to 3 hours for laws of motion and 2 hours for this. 4 hours you need. So I don't think you can send me before 11 o'clock. 30 question from chemistry and full 74 question from physics, including last time question. Like, you don't need to write new question. You can add question in the previous book where you wrote the remaining questions. There are around 30 questions, I guess. Yeah, 30 questions. Okay, so both chapter will be perfect, and both chapter you will have chemistry and physics in coming test along with the previous portion. Okay, tomorrow I'll have evening class, especially for the punishment, because don't feel like I forgot it. Just I'm delaying, so everybody should be there.
So
Okay.
tomorrow morning, what time will there be class?
Tomorrow morning, same 9:30.
Okay, sir.
9:30, 12, and evening.
Okay, sir.
Okay, guys. Bye. See you.
Thank you,
Thank you,
sir.
sir.
And in next
Thank
class,
you, sir.
we will also discuss the question from this.
Yes, sir.
Okay.